it is actually equal to perhaps E square upon 4 pi epsilon naught and H cross C. Okay. So that is so if you want to check its dimension, what you do is just divide by lambda and multiply it by lambda. Okay. So now here, you know that E square upon 4 pi epsilon naught and this lambda, this has dimension of energy. Okay, this has dimension of energy, and here we get here now H cross C or divided by lambda. So this also has dimension of energy. So energy by energy, this cancels out, and you get a dimensionless thing. So that is, its value comes out to be 1 by 137. Okay. Now another question number 3. See, these questions I have received from my students. They have given me memory-based questions. So some of the questions may not be exactly same as the questions asked in exams. There might be some slight variation. All right. So let's see. It says there is a matrix for which m dagger is equal to minus m and m to the power 4 is equal to identity matrix. See here, m dagger is equal to minus m. That means this matrix is a skew Hermitian matrix. And for skew Hermitian matrix, we know that eigenvalues are either purely imaginary or zero. Okay, so here you see purely imaginary eigenvalues are given in this. Okay, and in this one here there are some real eigenvalues also, so these are not possible actually. Okay, तो ये दोनों में से कोई एक possible होगा. Now we know that complex eigenvalues always exist in pair. One eigenvalue will be a complex conjugate of another one. Okay, so you see these are its complex conjugate is minus iota and its complex conjugate is again minus iota. So these are existing in complex conjugate pairs. But here eigenvalues are not in complex conjugate pairs. Okay, so that's why this one is correct actually. Okay. Now let's move to another question. See, this is a question from quantum mechanics. It says wave function is given to be this. Now question is eigenvalues of L square and Lz are actually. See, this wave function psi can be written as n and this z can be written as r cos theta in spherical polar coordinate. Okay. So here e to the power minus alpha and this x square plus y square plus z square will become equal to r square. So radial part of the wave function is this r e to the power minus alpha r square and angular part is cos theta. So angular part, which is represented by generally spherical harmonics, so it contains only cos theta term. There is no phi dependent term here. So this implies that cos theta power 1 is present. So that's why we will say that azimuthal quantum number L is actually 1 and this m quantum number will be equal to 0 because there is no phi term. That's why m will be equal to 0 here. Okay. And we know that now question says eigenvalues of L square. We know that eigenvalue of L square is actually L into L plus 1 or into H bar square. Okay, so this when we put L equal to 1, we will get here 2H bar square. Okay, and eigenvalue of Lz is actually equal to MH bar. When we put m equal to 0, we will get here 0. So that's why correct answer will be 2H bar square and 0, which is given here. So B option will be correct. Okay. Now let's see another question. It says minimum angle made by angular momentum with z axis for 2p electron. 2p, see, there is 2p electron. For a 2p, there is one 2p electron. So for this, L is equal to 1 है. Okay, so angle, actually that angular momentum, see, suppose this is z axis and this is angular momentum. The angle that angular momentum makes with z axis is actually given by, okay, we can write it as cos theta is equal to m divided by root under L into L plus 1. All right, L plus 1. So here we want minimum angle, right? We want minimum angle. So for that we'll have to calculate maximum value of cos theta. So here L is equal to 1. So M is actually equal to 1, 0 or minus 1 hoga. So to calculate minimum angle, we need to put maximum value of M, which is 1 here, and L is 1. So if you put 1 here, you get root 2. So that will be equal to cos theta. So we are getting cos theta equal to root 2. That means theta equal to 45 degree. Answer will be 45 degree. Okay. Now let's see another question. This is question number 6. This is a question from classical mechanics actually. See, the question says F. This is a central force actually. Central force is given to be this, and now dpr by dt is to be calculated. Okay. See dpr by dt if you want to calculate we can मतलब क्वेश्चन देखने से ही समझ में आ रहा है ऐसी आंसर is given in terms of momentum and coordinate, so obviously if we write Hamiltonian we should be able to get the answer easily using Hamilton's equation of motion. So let's do that. Okay, so here first of all force is given to be minus k upon mr cube. So from here if you calculate potential energy you get minus f dr. Okay. So put that here, this minus and minus plus, and you when you integrate it, you get again here minus k upon 2m and r cube, r square. That's what you'll get. So that's the potential energy of the particle or system, we can say. Now let's write Hamiltonian. So Hamiltonian is actually written like this: pr square upon 2m. Actually, ideally, what we should do is we should first write Lagrangian and then we can convert Lagrangian into Hamiltonian, but I'm doing it here directly. So P theta square upon 2m r square, and now potential energy will write. So this is like kinetic energy part, and now potential energy part we are writing, so which is given by here minus k upon 2m r square. Yeah, that's the Hamiltonian. So now we have to calculate dpr by dt. So according to Hamilton's equation, this is nothing but del h by del r, partial derivative of Hamiltonian with respect to r. Okay, this is Hamilton's second equation actually. This is pr dot. It is pr dot actually. So now let's differentiate it. See, there is no r term present here, so this term will be zero. Now here there is r term. When you differentiate this, you get minus 2 upon r cube. Okay, and 2 and 2 cancel out, and this minus makes it positive. Yeah, so this becomes p theta upon m r cube. And when you differentiate this term minus and again minus plus, but differentiation will give you a negative term. So that is k upon mr. I think we'll get here mr cube, something like this. Okay. I think I've missed something. This is what we have. All right. So when you differentiate this, you get this, and it was mr cube. Okay. I think it's all right. So I hope I haven't made any mistake. That's right, minus and minus plus, and then differentiation will give minus sign. All right. Okay, so when you take LCM, we get here m r cube, and this is p theta square minus k. Okay, so that's what we are getting here. Why m term is coming everywhere? I think I have written question something, some mistake is there in the question. Minus k upon mr cube. If I write here, it was it. Let me see the question that a student had sent to me, whether it was minus k upon mr cube or my mobile phone is also off. Okay, I'll come back to this question. I think, but this is the approach actually. See, I might have noted down it incorrectly. That's why no option is matching actually. There is factor of m coming everywhere. So there might be some mistake in the question. That's why, but approach will be this one actually. You write force, from force you calculate potential energy and write Hamiltonian and just apply Hamilton's equation, and you are getting something similar. You see, you are getting. So somewhere I have missed m term, or I have either written extra m term. That's what has happened actually. Okay. So let's see. Moving to another question. I'll come back to that question once my mobile switches on. Okay, it is off actually. Now let's see. U is given to be this and V is given to be this, and question says it is basically real and imaginary part of some analytic function. Okay, so we know that to solve this, what we'll do is, see, for analytic functions, we know that Cauchy-Riemann condition will be satisfied. So we'll write Cauchy-Riemann condition. Okay, so if you apply Cauchy-Riemann condition, you'll write like this: del U by del X is equal to del V by del Y. So now differentiate u with respect to x. So this is u. So what you do is multiply with by x term. Okay, you just open the bracket. So if you open the bracket, you will get here x cube and y minus x and y cube. This we get, and now we are differentiating this with respect to x, we are taking partial derivative here. So what we get here? 3x square and y minus. When you differentiate this one, you get here y cube, and you are differentiating v with respect to y partially. So this term becomes 0, and you get here 4b and y cube. And here you get 2c plus 2c x square and y. Now let's equate the coefficients of identical terms. See here, there is x square y, there is x square y. So we should get 2c is equal to 3. That this implies that c should be equal to 2 by 3. Okay. And oh sorry, I have written it should be 3 by 2. 3 by 2. And now when you equate coefficient of y cube, we get here 4b is equal to minus 1. So therefore b is equal to minus 1 by 4. Now let's apply another Cauchy-Riemann conditions, that is del u by del y should be equal to minus del v by del x. Okay, so partial derivative of u with respect to y is equal to minus partial derivative of v with respect to x. So now again u is this much, and we are going to differentiate it with respect to y. So when you differentiate this u with respect to y, you get here x cube minus, when you differentiate this one with respect to y, you get 3x and y square. And when you differentiate this v with respect to x, you get here minus 3a and x to the power 3. Oh, sorry, 4a actually. I made a mistake. So you get here 4a, and when you differentiate this term, this becomes 0. And when you differentiate this term, you get, there is an extra minus sign. That's why minus is coming. When you differentiate this, you get 2c x square and y. So now to calculate a, we'll equate coefficient of x cube. So you get here minus 4a equal to 1. So we are getting a equal to minus 1 by 4. Now we have to calculate the product ABC. So a multiplied by b multiplied by c will be equal to, see, a is minus 1 by 4. B we have calculated, it is also minus 1 by 4. And c we have calculated, which is equal to 3 by 2. So we are getting here 3 by 32. That's the answer. Okay, so this is option A is correct. Okay, first option is correct actually. So now moving to question number 8, it says there is a disk which is rotating in xy plane with angular velocity which is phi dot. Phi dot actually represents rotation about z axis. So it is rotating about z axis with velocity, angular velocity, which is 2. And here it is said that v represents velocity of a point which is on the disk, which is coordinate of the point is given to be rho, phi, and z on the disk. Then we have to calculate these things. Okay, so I didn't receive any exact number. Now, so in 4 options, these 4 things might have been given, and you have to check which one is actually correct. So some these values were given actually, but here I have left blank. Okay, so let's do that. So here there is a disk. Suppose this is a disk. Okay, or let me draw properly. Suppose this is a disk. So I'm just giving it a 3D view. Okay, now this is a suppose disk, and here this is the axis of rotation of the disk. It is rotating about this axis with angular speed omega. Now let's say there is a point, this I'm taking as origin, there is a point here. This distance is rho, and its coordinate of this point is rho, phi, and z. All right, so this point is actually will be moving in a circle like this. Okay. This point, when disk is rotating, this point is moving in a circle actually. So velocity vector, which we can say every point will have a velocity vector. So every point of the disk has a velocity. So at every point on the disk, we are defining a velocity vector. So we can say there is velocity field. We can say there is a vector field actually, or we can just say that there is velocity field here. So definitely for that field, vector field, we can define divergence, curl, etc. All right. And if we take magnitude of that velocity field, we can call it a scalar field. And for that scalar field, we can calculate gradient also. All right. So let's see. Here, velocity will be actually equal to, velocity is equal to, we know that it is omega cross, and this rho vector, we can write omega cross r. R will be actually equal to this position vector. So omega, see, the rotation is about z axis. So you can write it like this, omega and z cap and cross this row is rho into rho cap, we can write. And in cylindrical coordinate system, z cap cross rho cap actually gives us phi cap. That's what we get, right? We have rho cap, phi cap, and z cap. When you do this cross multiplication, when you multiply z cross rho, you get phi. All right. So this will be omega and rho, and here you get phi cap. So that's what we have actually. Okay. So now we can see this vector is actually rotating, and for rotating vector, actually we get divergence equal to 0. So here, if you calculate divergence, okay, for example, magnetic field also you get that. Okay, magnetic field is rotating around a wire, and if you calculate divergence of magnetic field, you get 0. So we can get that result by doing calculation also. But if you know something, to save time, you don't have to repeat all the calculations. So that's what we are doing here. We are not repeating the calculation. We'll directly write here divergence equal to 0, because this is a rotating vector. So if a vector is a rotating vector, we can take its divergence to be equal to 0. All right. So therefore, a divergence here we have to calculate, its answer will be 0. Okay. And if 0 is given, then that will be correct option. All right. Now we have to calculate, for example, del square. So let's do that. Del square v. So let's use cylindrical coordinate system. So in cylindrical coordinate system, del square is written like this: 1 by rho square and d2 v. If this v vector is there, v vector by d phi square. All right. This we have to calculate. I'm not sure whether it was v vector or v magnitude. Okay. So I think v magnitude is there. So if v magnitude is there, we can just write like this. All right. Now you see here. So here velocity vector is this much. Its magnitude is omega into rho. So if you calculate magnitude here, it is omega multiplied by rho. All right. So it doesn't contain any phi. See, answer for del square v vector and del square v magnitude will be different. Okay. If you calculate del square v vector, answer will be non-zero. But I'm not sure whether it was v vector or v. Both can be calculated. Okay. Del square v vector as well as del square v. So let's assume that it was del square v magnitude. Okay, तो अगर magnitude है क्वेश्चन में दिया हुआ, तो यहाँ पे 1 by rho, and since v magnitude doesn't contain any phi term, so this term will become 0, so answer will be 0. But if it is del square v vector, then for that calculation you will have to convert this phi cap into Cartesian coordinate I cap and j cap, and then you will be able to do this calculation. Okay, so answer will involve in that case phi also. Okay, there will be phi term in the answer. So so what I am doing is I'm writing that also here. So suppose you calculate here del square v vector. Del square v vector आप निकालेंगे तो देखिए यहाँ पे 1 by rho square होगा, और and here you will write del square v vector by d phi square. Okay, we'll get something like this. But v vector contains phi cap. So what I'll do, I'll express phi cap in terms of I cap and j cap. So in cylindrical coordinate, if you do that, you get something like this: minus sine phi I cap or plus cos phi and j cap. This you get. So actually, when you differentiate del square v, see again this magnitude doesn't contain this. There is no phi term present here. Phi term is actually present in this phi cap. So when you differentiate phi cap twice with respect to phi, you will get back the same thing. Okay, with a extra negative sign. So here you will get here 1 by rho square, and from here you will get omega into rho, and when you differentiate this phi cap twice with respect to phi, you will get here minus phi cap again. Okay, you'll get minus phi cap. All right. So therefore, answer in that case will be omega divided by rho and minus phi cap. So now you can check what was given in the question. Okay. Most probably, I think del square magnitude of v is to be calculated. Okay. All right, so these things we have now. Now let's calculate curl. Curl was to be calculated. So curl of v vector, if you calculate, okay, it will be equal to 1 by rho, and here you get rho cap, and here rho into phi cap and z cap, and here dd rho, and here dd phi, and here dd z. And here you get components of the vector. See, vector has only phi component. So this will be 0 and z component will be 0. And here it will be multiplied by scale factor rho. So here it will become omega rho square. Actually, when you write here phi component, you multiply it by scale factor. So that is scale factor is rho here. So that's why rho omega into rho will be multiplied by rho. So it will become this one. All right. So when you calculate component row component, okay, you will leave this column, this row. Phi operating on this will give 0. This will 0 be 0. When you calculate this phi component, you will be left with only 0 0. So that will be 0 again. You calculate z component. Okay. So row operating on this will give you 2 uh, operating on this will give you 2 omega and rho, and we are calculating z component, so we'll get z here. Okay, so rho and rho will cancel out, so you will get 2 omega and z cap. That's the answer. Omega is given to be 2 actually. Okay, na? See, omega is this phi dot. This phi dot is actually omega. Okay, so here you get 2 into 2, so z cap, so that is equal to 4 actually, 4 z cap. If you calculate curl, it will be 4 z cap. Okay, now last one, this gradient of magnitude of speed. So this if you calculate gradient of magnitude of speed, sorry, velocity, magnitude of velocity, so this is basically scalar field now, so we can definitely calculate its gradient. So this will be see it is a function of rho only, so we'll get only this term rho cap and dv by d rho, because there is no phi or z term present here, so we are not writing other two terms that we get here. Okay, so this will be actually equal to rho cap and omega. So if you calculate its magnitude, grad v modulus, so that will be equal to omega, and omega is equal to 2, so answer will be 2 actually. Okay, so this was somewhat longer, this involved somewhat longer calculation, because lots of calculation had to be done for a separate calculation had to be done for each option. Okay, that's why it was somewhat long question. Okay, now let's move to another question. See, it says for z, this question was not very clear. So I assumed it says for z equals 0, spectroscopic notation for ground state is. Okay. So what I will do is we'll write electronic configuration 1s2, 2s2, and 2p2. So there are 2 electrons in p orbital. These 2 are equivalent electrons. So if you write all the term symbol, you will have to use Bridge scheme. So we are not doing that. Okay, we are just writing the ground state, which is easier to do actually here. In p orbital, see there are 2 electrons, so we'll fit the 2 electron according to Hund's rule. Okay, so now for ground state, we want maximum spin. So therefore, spin of the 2 will add, and that will give us s equal to 1. And here, if you sum the ml values, here you will get ml equal to 1, and this ml equal to 0. So therefore ml is 1, so therefore L will be also equal to 1. Okay, now this is less than half field, so you get j equal to L minus s. Okay, so we'll get 1 minus 1, which is 0. So therefore term symbol, if you write, you get here 2s plus 1, and here for L equal to 1 you get p symbol, and here you get j. So put s equal to 1 here, so 2s plus 1, 2 into 1 plus 1, that will become 3. So you will get 3, j value of j is 0. So this 3p0 should be the correct answer, this one. Okay, so that is the spectroscopic term for the ground state. Now this question, this is I think a question from solid state physics. A student has just drawn this figure and sent to me. So obviously it is E versus K energy band diagram है ये, ठीक है? This is energy band diagram, and for 3 different bands we have. Okay, and these are nothing but actually effective masses. So we have to looking at this graph, we have to tell which one is correct actually. Okay, तो देखिए इसमें ग्राफ एक जैसा ही है, ठीक है. सो वी कैन आंसर दिस क्वेश्चन विदाउट गोइंग इनटू मच डिटेल्स if you have just a little knowledge of mathematics. Not much of solid state physics is required here. Okay, so what I'm going to do, instead of just looking at the graph and analyzing the options, I'm going to use some mathematics. Okay, so a little mathematics will help us figuring out the correct option. So let's do that. So we know that in solid state physics, effective mass is written like this: h square and divided by d2e by d a square. So what I'm going to do here is, see, this second derivative actually equal to is actually related to radius of curvature. See, here So what I'm going to do is I'm going to relate it with the radius of curvature. See, the question is not very clear, but let's calculate radius, because effective mass is different at different points for a band. Okay, so here we are going to calculate effective mass, suppose at or here at origin. Okay, at this point let's calculate. Okay, so what I'm going to do is I'll relate this second derivative with radius of curvature. See, radius of curvature formula in mathematics, we know that there is a formula 1 plus it is dE by dk whole square power 3 by 2. Okay, just a minute. Okay, and here you get d2e by dk square. So at this point, see, if you draw tangent, it is parallel to k-axis. So therefore, this term will be 0 actually. So here, in place of d2e by dk square, this will become 0. So d2e by dk square will be equal to 1 by r. So here, we can write 1 by r. So therefore, we will get effective mass equal to h bar square or into r. So therefore, higher the value of r, higher will be the effective mass. Obviously, we can see that for this A radius of curvature at this point will be largest because this is wider graph. Okay, and for C radius of curvature will be smallest. Okay, so therefore largest radius of curvature is for this one A के लिए है and smallest radius of curvature is for C actually. तो इसीलिए effective mass will be largest for A. तो इसलिए first option correct हो जाएगा इसमें. ठीक है, first option is correct. Now let's move to another question. It says under time reversal and parity, which of dipole moment and magnetic moment is odd or even? So ये बहुत ही basic question है. This is generally discussed in all classes of nuclear and particle physics. See, here dipole moment. See, we know that dipole moment is defined like this. Dipole moment is defined like this. P is equal to, suppose there is discrete distribution of charges, then we can write it as Qi and Ri vector. Okay, and magnetic moment, we know that it is defined like this, some summation on current and area vector. You can write it like this, area vector. Okay, summation on I. So that's the basic definition of magnetic moment and dipole moment. Okay. Now see, under parity, when you do parity transformation, what we do is R goes to minus R. That's what we do in parity transformation. And time reversal transformation, if we do time reversal, we replace T by minus T. That's what we do. Okay. So here, see, this magnetic moment can be written like this also, dq by dt, dqi by dt, we can write like this, and si, summation on I. See, this is area vector. It is a pseudo vector actually. See, under parity, it doesn't change its sign. Okay. So under this is pseudo vector. Okay. Area vector, it doesn't change its sign, or axial vector, you can say, it doesn't change its sign under parity transformation. Okay. So what will happen? See, under parity, charge doesn't change. Charge remains same. Okay. So this will not change under parity, but this will change its sign. So therefore, under parity, we can say that this dipole moment is changing its sign. So therefore, देखिए अगर हम इधर dipole moment लिखते हैं और इधर magnetic moment, और let us write here like this. Here I'm writing here parity, and here I'm writing time reversal. Okay, time reversal. So let's see what. Under parity, we can see R goes to minus R, so there will be negative sign, so it will pick a negative sign. So therefore, we can say that dipole moment is odd under parity. This is odd. But if we do time reversal, there is no time present here. Okay, so this will remain as it is. So under time reversal, it is even. Okay, magnetic moment, see, this is as I mentioned, this is axial vector or pseudo vector, we can say. It doesn't change its sign under parity, so S will not change under sign its sign under parity, and there's no R term present in current. So therefore under parity this is not changing sign, this is also not changing sign, so this will be even. Okay, so this is even under parity. And under time reversal, this T will become negative. Actually, this T will pick up a negative sign, and this doesn't contain in T. So under time reversal, this will become negative. So therefore, it is odd under time reversal. So this magnetic moment is odd under time reversal. Okay, but so this is what we have actually. Okay. So now accordingly, you can take the option. All right. So now moving to this question, see, it says omega, that is the angular frequency of a simple harmonic oscillator, and we have to write partition function. So we know that partition function, let's see, partition function is written like this, summation and e to power minus beta and EIE, and here we write degeneracy also, GIE, okay, summation on I. Now you see here, actually this is for 1D harmonic oscillator, so degeneracy for each state is equal to 1 actually. So we can write G equal to 1. So we have here e to power minus beta, and energy is written like this, h cross omega n plus half. So now we'll do summation on n actually. We'll do, see, I'm going a little fast because I don't have to explain everything here. I'm just providing you a quick solution. Okay, so I'm not going into the very much details of each step. Okay, so here what I can do is I can write beta h cross omega and divide by 2, and here we will be left with e to power minus beta and h cross omega and n. All right, and there is summation on n. Obviously n goes from 0 to infinity. So now here you see beta, here you see this is given to be 2 kBt. So we can write it like this also, 2 divided by h cross omega, and kBt becomes equal to 1 by beta. So in place of omega, if you write this 2 divided by h cross beta, so h cross beta will cancel out and 2 will also cancel out. So this becomes e to power minus 1, and there is summation on n from 0 to infinity e to the power, here you get minus 2 n actually. Yeah, when you put omega equal to this 2 divided by h cross beta. So that's the summation. So e to the power minus 1, and you sum it over, you get here 1 e to the power minus 2 plus e to the power minus 4 plus e to the power minus 6, and so on. So this is a GP series with common ratio less than 1. So therefore we get here, this is first term divided by 1 minus common ratio, which is minus 2. Okay, so this gives us actually e divided by e square minus 1. So that's the answer. Okay, so that's the this is C option is matching actually. Okay, so that's the question number 12. See, I received some questions. I have selected some of those questions. Okay, some questions were not very clear, so I have just I'm discussing here 15 of those questions. Okay. If I receive some more clear question, I'll make another video. Okay. The question is related to Joule-Thomson effect, which is very well-known phenomenon. See, it says Joule-Thomson effect. We have to take the correct option. We all know that Joule-Thomson effect occurs at constant enthalpy. So this is isoenthalpic process. Okay. In Joule-Thomson effect, enthalpy doesn't change. And we also know that in Joule-Thomson effect, cooling as well as heating can occur. We know that when this experiment is carried out at temperature which is greater than inversion temperature, then heating occurs. And when temperature is less than inversion temperature, then cooling occurs. Okay, so results in heating as well as cooling as well as heating. This option should also be correct. Okay, and it says that for ideal gas, it always results in cooling. That is not correct. Actually, ideal gases do not show Joule-Thomson effect. Okay, so this is a wrong option. Now, it is related to Hall effect. It says rho xy varies with beta. So this is a very direct question from theory. Anyone who has studied this Hall effect knows that rho xy, sorry, rho xy is given by some formula. There is a omega c tau and divided by sigma naught. So omega c is actually equal to qb or divided by m, and this is tau divided by sigma naught. Okay, so that's what we have. So now you see rho xy is proportional to b. So therefore, if you we can say that rho xy is proportional to b. So therefore, graph of rho xy versus b will be equal to will be this one. Okay, so it will be straight line. All right. Now let's move to another question. See, this question is related to quantum mechanics. It says wave function in coordinate space is given, and now you have to plot this probability density in momentum space. So we can obtain this rho phi. Rho p, phi p, it is written. So this is basically wave function in momentum space. So we know that if wave function in coordinate space is given, we can find wave function in momentum space using Fourier transform. So we'll have to calculate Fourier transform of this function, and we'll get this, and we will plot it. Okay, but we don't have to do all those things. See, this question we can say that is either related to quantum mechanics or it is a question of optics also. ठीक है, ये ऑप्टिक्स का क्वेश्चन भी कहा जा सकता है, बिकॉज वी नो दैट इन ऑप्टिक्स डिफ्रैक्शन पैटर्न इज नथिंग बट ए फूरियर ट्रांसफॉर्म ऑफ द डिफ्रैक्टिंग स्लिट. तो डिफ्रैक्टिंग स्लिट जो होता है ना, उसका फूरियर ट्रांसफॉर्म अगर आप निकालते हैं, देन यू गेट डिफ्रैक्शन पैटर्न. ओके, do remember this point. So here see, this is nothing but a window function. Okay, within this interval of width 2a, there is some value of this function which is equal to m, and beyond that this is 0. Okay, so it is actually representing a window function. Window function is equivalent to actually a slit. Okay, window function is equivalent to a slit, and we know that when we take Fourier transform of this slit, we get a diffraction pattern on the screen. Okay, in front of a diffraction. Okay, so if we take Fourier transform of this window function, we get diffraction pattern, and we know that for single slit diffraction pattern is actually this one. This is the intensity distribution in diffraction pattern. So that's why we are very much sure that if we take Fourier transform to obtain phi p, and when we plot phi p, we will definitely get this. तो इसको हमें सॉल्व करने की जरूरत नहीं है, हम इसको डिफ्रैक्शन से रिलेट करके आंसर कर सकते हैं कि ये एक विंडो फंक्शन है, और विंडो फंक्शन का जो डिफ्रैक्शन फूरियर ट्रांसफॉर्म होता है वो डिफ्रैक्शन पैटर्न देता है, और सिंगल स्लिट का डिफ्रैक्शन पैटर्न तो यही होता है. ठीक है, तो ऑल्दो इट इज अ क्वेश्चन ऑफ क्वांटम मैकेनिक्स, वी कैन रिलेट इट टू for diffraction, and so basically this is a question of quantum mechanics, or you can say it is a question of mathematical physics, because it involves Fourier transform, and we can also say that it is a question related to diffraction. So it is a very interesting question actually. Okay, so that's all I'm discussing in this video. Maybe I'll make another video of questions that I receive, but questions have to be clear. Okay, if you want to send, if you have more questions and you want to send those questions, you can WhatsApp me. This is my WhatsApp number. Just no, my WhatsApp number is 8750270363. You WhatsApp questions on this number, I'll make another video. All right, so thank you very much. Let's stop now.